Welcome students, let us see some more subtopics from the chapter sets. So we are discussing a very important topic, important term which is called subset. So we will try to understand what is a subset, how to define it, we will discuss it. So let us start discussing this topic subset with the help of an example. Suppose set A is having elements A and B, and set B is having elements A, B, C, D and E. Here we observe that elements of set A means A and B, both the elements are available in set B also. All the elements of set A are available, are present in set B. In this case, set A is called subset of set B. So, how we can define it? If each and every element of set A is present or available in set B, then set A is called subset of set B, and this is denoted as this notation, this notation this is read as A is a subset of B. Okay, so this is the notation for subset. And suppose you take another set C having elements A and K. Okay, so tell me whether this set C is subset of B or not. No, this is not a subset. Why? Because here K is an element of this set C which is not present in set B. So here we will see that this set C is not a subset of set B. Okay. So if A is a subset of B, we represent it like this with the help of this notation. And if any set is not a subset, we use this notation to show that not a subset. Very simple, very clear. So we can understand that set of all the natural numbers are subset of set of real numbers. Very simple. Okay. Now we will discuss what is a proper subset. Proper subset. Here I would like to make it clear that every set is a subset of itself. Means you can write that A is subset of A, because both the sets are same, both the sets are equal. So all elements of this set A are also present in this set A because both the sets are equal. In this case, along with this notation, we put a sign like this which indicates the sign of equality. So if both the sets are equal, then also it is subset, but we put this equality sign here. Okay, but a proper subset cannot be equal. Number of elements in set A is always less than number of elements in set B. Okay, so let us try to understand what is a proper subset. If set A is a subset of set B and at least one element of set A is not present in set B, then set A is called proper subset of B. And there is no difference in writing. Here we write A is a subset of B. Means also here to be understood that NA is less than NB. NA means cardinal number of set A, means number of elements in set A. So in the case of proper subset, number of elements in set A should always be less than number of elements in set B. Correct? So this is called proper subset. And if here A is a proper subset of B, then B is called superset of set A. Superset. If A is a subset of B, then B is called superset of set A. Okay? Here A is a subset of B, then B is superset of A. Correct? Now let us discuss equal sets. Equal sets. We have already discussed in previous video what is equal sets. If there are same numbers of elements, same elements in fact, in two sets, then both the sets are equal. I am repeating it. If two sets A and B are having same elements, so obviously number of elements will be same as well as elements are same in two sets A and B, then A and B are called equal sets. But with the help of this definition subset, we can also prove that two given sets A and B are equal. Okay? So two sets A and B are equal if set A is a subset of B and B is a subset of A. Clear? Or you can understand that A is equal to B if I am giving arrow in both the directions. A is a subset of B and B is a subset of A. Means if this is holding, this will hold, or if this is holding, this will hold. That's why both the directions I am writing. Means if, if and only if. So A is equal to B if A is a subset of B and B is a subset of A. Or conversely, if A is a subset of B and B is a subset of A, then A is equal to B. Later on, we will see some questions using Venn diagram or some other way. We will be required to show that these two sets are equal, A is equal to B. Then it will be sufficient to show that A is a subset of B and B is a subset of A. Then automatically these two sets A and B will be equal. Okay. Now let us see some notes. First, every set is a subset of itself. Every set is a subset of itself. That is, if A is any set, then we can write A is a subset of A. So as per the definition, we have understood that if every element of the set A is also present in set B, then A is subset of B. Here in this case, since both the sets are equal, so all the elements are available in both the sets. So there is no question that A consists of an element which is not available in this set. Means all the elements which is contained in this set A are also available in this set A, because both the sets A are same, isn't it? So here we can make a conclusion that every set is a subset of itself. Second note, empty set, or which is known as null set also, null set is a subset of every set. You know, null set is denoted by phi. So phi is a subset of A, or phi is a subset of B, where A and B are two given sets. How we can justify it? How we can show it? How we can prove it? Very easily, in one line statement only, that we know that this null set, this empty set is not having any element. This set is no having any member, no having any element. So if this null set phi is not consisting any element, any member, then the question doesn't arise that null set is having an element which is not available in set A. Understood? When we can say that null set is not a subset of A? You see, on contrary, let us write phi is not a subset of any set A. What does it mean? It means that this null set is having an element which is not available in set A, then only it is not subset. That is, any element of null set phi is not in set A. But this is not possible. Why? Because phi is not having any element. Phi is empty set. So this question doesn't arise. Which question? That any element of phi is not in A. There cannot be any element. So this is contradictory. So you can write, but phi has no element, empty set has no element. So this part is contradictory. So therefore, there is no element in phi which is not in A, because null set consists no element. Okay, so what does it mean? This contradiction shows that therefore null set or empty set or phi is subset of every set, isn't it? So we understood that every set is a subset of itself. Second, we understood empty set is a subset of every set. And third note, that empty set is unique or null set is unique. How we can prove it? Null set is unique. See, let phi 1 and phi 2 are two distinct, on contrary, we are starting on the basis of contradiction. So phi 1 and phi 2 are two distinct null sets. And we know that null set is a subset of every set. Also, null set is a subset of every set. Null set is a subset of every set. So therefore we can write that phi 1 is subset of phi 2, and also since phi 2 is empty set also, so you can write phi 2 is a subset of phi 1. So by the condition of equality of two sets, equal sets, if A is a subset of B and B is a subset of A, then A is equal to B. Similarly, if phi 1 is a subset of phi 2 and phi 2 is a subset of phi 1, what does it show? It shows that phi 1 is equal to phi 2. So this is unique. It has been proved. Correct? So these are some very basic terms in the chapter sets, and we have understood it. In the next video, we will see some more topics, we will discuss some more topics, and later on we will see some problems also related to these topics in other videos. So students, keep in touch with this video and enjoy learning mathematics. Thank you very much. Wish you all the best.